Hello, everybody. Thank you for having me. So today we'll speak about public or private 5G and how to ensure continuity between these two worlds. So first, let me introduce myself. I'm Romain Durand. I'm a co-founder of Transatel, and I'm heading the research and innovation activities within the company. So a few words about Transatel first, because you may not know us. Transatel, we are a French company. We've been created 22 years ago, and we provide cellular connectivity services beyond borders. So essentially, we are providing a single SIM card, allowing to provide mobile broadband access worldwide. And we have designed this service typically for any device maker that is looking for cellular connectivity service at a worldwide scale. Because obviously it's possible to get a SIM card from your operator when you are in your country. So local SIM cards are quite widespread, but global SIM cards are much more difficult to use. Typically, it's for economical reason, you cannot use a European SIM card in Asia or in America when it comes to mobile broadband. So device makers that are global brands are looking for this kind of global solution. So again, essentially our offer is a SIM card, one unique SIM card, allowing local prices worldwide. And also because we have set up we have our own infrastructure. We are what we call the mobile virtual network operator. We have one unique platform allowing us to provide our services. So when we put in place some dedicated services for our customer, they are available in any countries. So to do so, we have established our infrastructure, and we have signed a bit more than 190 access agreements with public mobile operator worldwide, allowing us to provide our services. And we have been acquired by the entity group 3 years ago. We are now part of this huge Japanese group. To go into some more examples regarding our activities, we are addressing several segments. So the first one is industry and services. It's general IoT use cases. So maybe our most famous customer here is Airbus, the airplane manufacturer. Airbus is providing predictive maintenance services. So they need to collect data from sensors in their planes during the flight. And as soon as the plane lands on the ground, it sends all the data to an Airbus server. And to do that, they need a global cellular connectivity solution. We also have the vehicles, the automotive industry. As you know, more and more vehicles are connected nowadays for emergency services, for telematics, infotainment. And the car manufacturers are global brands as well. They need to have a global solution for their connectivity offering in the car. And typically we have Jaguar Land Rover or Stellantis, Fiat Chrysler Automotive as customer. And last, we have the connected devices, whether it's laptop, tablets, or even smartphones. We had a partnership with Microsoft a long time ago to embed the eSIM within Windows 10. And now you have some PC that are connected in cellular with 4G and now 5G. And typically, for example, in Microsoft Surface, we embedded by default our connectivity solution. All these customers, we are more in B2B offers, but we have also a B2C offering called the UBG. If you have a smartphone which is eSIM capable, you can download the UBG application, and from there you can download a connectivity profile that you will be able to use when you travel abroad to avoid roaming charges. So that was for Transatel. Let me jump into the topic of today, which is public or private 5G and the continuity between those networks. First of all, the private 5G network itself, why it is important, and what are the main characteristics. So private 5G is essentially a local connectivity bubble that you can have in your premises, whether it's an industrial site such as a port, a mine, or manufacturing plants, automotive manufacturing factory floor, for example. But there are also many other use cases, campus, hospitals. So within this local area, you can have your own private network. So it's like the public network, but at a very small scale. And the main advantage is first high performance, especially with 5G. You have high bandwidth, low latency, high reliability. That's one first characteristic. You also have, and this is very important for enterprises, security and privacy of your data. Typically on an industrial site or in a factory, there's a lot of sensitive data from the customer perspective, and they simply don't want this data to be sent over the public network. Then having your private network can also be a cost saving, because if you need to use cellular connectivity and you have a lot of data, mobile broadband, then it can be very expensive on the public network. On the private network, it's internal, so it's your own costs. And last, you have some characteristics for 5G compared to Wi-Fi, which is mobility and security, which make private cellular network an interesting option for enterprises. If I'm going into the different flavors of architectures, there's different architecture for private networks, spanning from the standard public network on the left to the full standalone private network on the right. So the standard public network is the public network that we are using for smartphone. If you are an enterprise, you can negotiate some deals with public network operators to have a more premium offer, for example, specific SLAs or specific customer support, but it's still public network. Then with the advent of 5G, we have what is called the slicing feature. A slice is a way for a public network to allocate a specific part of its network for a specific customer. So it's kind of dedicate some resources to a specific customer. It allows some security and isolation, but it's still on the public network. Then you have some hybrid solutions, so where you mixed public network elements and private network elements. So typically you may use a public network, but have your own antenna in your premises or your own mobile edge computing system. And then on the left, it's the full private network model, where you have all the private network components on premises, meaning the antenna and the core network. And you need to broadcast some signals, so you need some spectrum. And there are here two possibilities. Either you use the spectrum from the operator, or you use your own spectrum. This depends actually on local regulation, because getting your own spectrum may not be easy. That's why renting the spectrum from the public network operator can be easier in some countries. But more and more, we've seen that there's some spectrum dedicated for private networks recently. So if we look back, we see that the more we go on the right, the more customization we have, the more control we have, the more security we have. So a lot of advantages. On the other side, it's more costly, especially because you need to invest in some equipment, and you also need to invest in some skills, because usually the user of private networks are not telecom operators, so they need to invest heavily in that. So by the way, as I mentioned, we are part of NTT. NTT has a private network offering, which is a private network as a service. So that can be a good trade-off, because it's really the standalone mode. It's your private network in your premises, so purely standalone mode, but still it's managed services. So the skills are brought by an entity. Entity build and operates your private network on your behalf. So if we look into this survey from Omdia, we see that currently the deployments of private network on the market are mainly standalone networks. So 68% of the deployment, the active deployment today, are the standalone network where everything is on the on-premises, the antenna and the core network. And we see that there is a trend maybe in the future where we will see more hybrid solution with this mix of private network components and public network components. So up to now it was private network. So let me jump into this continuity between private and public network. As I said, the private network is it's a connectivity bubble. So usually you have your private network and your private SIM card, and this private SIM card can be only used within the coverage of the private network. And it's okay for many use cases. But still what we have seen recently is that there are more and more demands to be able to use the private SIM card outside of the coverage of the private network. And typically, this is some examples that I can mention. First, in the aviation, that's a topic we know well because we provide Airbus with our public connectivity service. So as I said, Airbus is collecting some data during the flight and need to transmit this data over cellular networks when the flight lands on the ground. Currently, they are using public cellular network, but as you may know, there are more and more airport private network deployed all around the world. So the idea would be to say, okay, when a private network, an airport private network is available, why not using this airport private network with more capacity? And that could be interesting for Airbus or for any other aircraft manufacturer. So second use case would be the distributed workforce, the employees. So if you have your private network on premises, obviously when your employees are on site, you want them to use the private network with their connected PC or tablet or smartphones. But these employees are not always on site. They are commuting, they are also on the go, so they don't want to be able to switch SIM card every time they go outside of the private network. So we have seen these requests many times of being able to use the same SIM card in private and public for employees. And last example that we have seen many times recently is in the automotive industry. So as I said, the cars are connected and are using public network when they are on the road. But before being on the road, they must be constructed in the factory. And within factory, you have more and more private network that's used during the production process. Typically, for example, to download the latest software data at the end of the production chain. So you want to have the car to use the private network during the production process, and after automatically switch on public network when it will be shipped outside of the factory. So even if private networks are essentially private, we've seen that there's some, in many cases, this question of, okay, how can we ensure the continuity to public network? So let me jump now into the possible solution to concretely implement this continuity. Well, we have two main solutions. The first one is what is called the roaming. The roaming, I'm sure you know what it is. It is when you are using your SIM card abroad, the SIM card from your home network operator can be used on another operator. And this is because there is an agreement and an interconnection between the visited operator and your home network. So this solution, this roaming agreement solution, is what can be seen as the most obvious one from a telecom engineer perspective. But it is not so easy in the private network context. First of all, you need, as a private network owner, to negotiate and sign roaming agreements. So you need to go and see a public network operator. And this negotiation may be difficult because you are very small. You are a very small network. You have only tens, hundreds, or thousands of SIM cards at most. So you are not really a big, interesting opportunity for the public network operator. But let's imagine you can sign this agreement. Then you need to interconnect with the mobile operator. So you need to indeed establish the roaming agreement. So this means interconnections. This means also that your private network must have the roaming functionality, which is not always the case in the private network. And once you have established the interconnection, you need also to pay for a third party because the roaming agreement between operators is not direct interconnection agreement. You go through some kind of hubs called GRX providers. And you need also to interconnect to what is called data clearinghouse for billing consideration. So these third party are expensive and it's extra cost. So globally, the roaming agreement solution is possible. And by the way, we can support it at Transatel, but it may not be relevant for all use cases. So what we have designed at Transatel is another solution which is much more simpler and has much more advantages. First of all, so it's a SIM-based solution. So it uses a SIM card, simply a SIM card, and essentially within the SIM card, you will have both access to the private and the public network. You can consider it as a private SIM card and a public SIM card in the same SIM card. So all you need is a SIM. You don't need any interconnection. You don't need any third party. And it's really separated environments. The only linking part is a SIM card. So this makes it a solution which is very secure and secure by design because both environments, the private network and the public network, are separated. And also it's a very controlled solution, and I will come back later on that. So Transatel, we are not the only one to support this solution right now, but one good advantage of using Transatel is if we implement this solution with us, from the public network perspective, we bring our 190 agreements. So doing this with us make it a solution that can be deployed all worldwide at once. So let me go into a little bit more detail about this SIM-based solution. So what it is, within the SIM, you have actually what we call an IMSI orchestrator. So the IMSI is the identifier on the network. And the IMSI orchestrator is an application that we have developed in-house that can manage several IMSI, so several lines, several SIM inside the same SIM. And this IMSI orchestrator is in charge of managing these several IMSIs and to manage the switch between one and the other. Then we have the credential, because the SIM is the authentication link into the public cellular network. So it has some credentials, some secret inside. So we have actually two separate space in the SIM that are really clearly separated. In one space, we have the credential to access the public network, and the other space, the credential to access private network. So Transatel, what we provide is this SIM card with the IMSI orchestrator. We provide also the credential to access public networks, thanks to our global mobile virtual network operator. And our customer provides simply the credential to their private network. So once we have that, we have a SIM card that can either use public network or private network. So I mentioned about the control. So how do we switch from one network to another? That's the question. So obviously we have first the obvious method, which is an automatic method. In most of the cases, you want your SIM card to be on the private network under private network coverage. And when you go outside of the private network, you want the SIM to switch to public network automatically. You don't want to take care about anything. And vice versa, when you come back from outside, from the public network, and you enter in your private network coverage, you want the SIM to switch automatically to the private network. So this is the automatic mode, which is supported by the solution, which is also supported, by the way, by the standard roaming solution that I was mentioning earlier. So that's something which works. However, it's a bit tricky when you come from the public network to the private network, because usually you have both networks at the same time. You have public network and private network that are overlapping. So in the automatic solution, you are dependent on the device behavior, and it's the device who decide himself about the automatic switch. So you may want to have what we call the controlled solution, the controlled switch, where you want a more fine-grained control about when do you switch to private and when do you switch to public. So to do so, what we have developed in our SIM is some API that we provide to the external world, so typically to an application in the device. And through this API, the application can control and decide very precisely when the switch occurs between private and public. So for example, you may have a switch based on precise GPS location. When you arrive within the enterprise premises, then you switch automatically to private. Or maybe when it's 8 o'clock, you switch to private. Or maybe when you, if it's a smartphone that the employee has, when the employee arrives, he taps at the entrance gate, and then there's an NFC detection, and automatically it switches. So we can think about any use cases where you want a more controlled switch mechanism. We have also this use case, by the way, it's not written here, where you have your private network, and suddenly your private network is done. So usually the private network needs to be there, but there may be some situation where indeed it's done. So in that case, you would like to switch to public network as a backup solution, as a resilient solution. So we can think about a lot of different use cases, so that having an automatic solution is not always the best option. So with our solution, we can have both automatic or controlled. So this is more or less what I wanted to say. So in a nutshell, what we see the advent of private network more and more, obviously. We have seen this request for continuity of service between private and public network, a real need for this continuity. And we assessed that the standard roaming agreement is actually not so relevant for this kind of private network offering. So hopefully we could find a solution, and this solution is a simple and neat SIM-based solution. So that's it for today. I'm happy to answer any question you may have. Thank you.
I think our audience have got their mind on lunch, Romain. But anyway, I've got some questions. So I thought something that was really interesting that you discussed there was that continuity from the private to the public. And I hadn't really thought about that very much, but that continuity needs to be absolutely seamless, or else once, whether it's an aircraft or a car or whatever it is outside your private environment and goes into the big wide world, if that continuity is not perfect, you've got big trouble. And indeed, possibly on some big machines, yeah. Okay, so I also think that, and I feel a bit frustrated, as no doubt so do you, that this whole issue with roaming is yet to be solved, that continues to be a sort of issue. I mean, that we haven't got beyond roaming as we think of it as consumers, really, for kind of industrial applications. That still seems to be quite a tricky area. Do you see any real progress there? I mean, this is something we've been talking about for years.
Yes, about what, sorry?
About the roaming.
Yes, the roaming. Yes, indeed. Well, we've seen, actually, when Transatel was created 22 years ago, there was still roaming in Europe.
Yeah.
So it took 10 years so that roaming were avoided. So we've seen roaming. So roaming was designed for consumer at first.
Yeah.
And roaming in IoT is possible. And actually, there's a lot of use case in IoT where roaming is used. And it's okay if you have some small usage, because yes, you can use, for example, a Japanese SIM card in Europe for roaming. For let's imagine you have a tracker device and you want to just send some small data usage. Then you could use roaming, but it's really,
I mean, for industrial usage, though, it's not. We don't seem to have evolved the model. Sort of, we don't really seem to have scaled it or changed the scope of it for use in more industrial.
Yes, actually, after one of the reasons is that the industrial were not really represented within the
standards bodies,
mobile ecosystem. So all this roaming, all this stuff are decided inside GSMA, which is a Mobile Operator Network Association. So more recently, actually, we started to have some changes where the industrials, for example, vertical car makers, are now invited inside the GSMA. So we have these discussions. So we have more and more some collaboration between the mobile network operator and the rest of the industry. But I admit it's not easy. And that's why some industrials decided to say, okay, I will not wait for the operator and I will do it myself with my network. And some industrials have also this thinking that, okay, mobile connectivity is too much important to let this to a mobile operator. That's why this private cellular network has received a lot of interest recently. So we have seen a trend of private network development in the market, and it's only the beginning, I guess.
Okay, well, we had a really outstanding speaker on Monday, actually, who talked about, not Monday, I'm talking rubbish, about why IoT and operators are not enjoying great success. There's some big other stuff that needs to happen. I thought it was really, really interesting, and you've kind of reinforced that, but it does at least sound like there's a bit more attention being paid now.
Indeed.
We hope. Anyway, Romain, thank you very much. That was great.
Thank you
very much indeed.